Alright, we're going to talk about inverse functions today. Alright guys, before we dive into inverse functions, let's revisit inverse operations such as addition and subtraction or multiplication and division. Remember, those were operations that kind of did the opposite or undid each other. Well, we can also have functions that are inverses, such as f of x equals 8x, and then also g of x equals 1 divided by 8x. So these functions would undo each other just like inverse operations would. Alright, another term or thing we need to know is a one-to-one function. So here's a kind of a book definition of what a one-to-one function is. Basically it says if a can't equal b, means that f of a can't also equal f of b. So in other words, every x value should have a different y value. So there's no repeating x and repeating y values for it to be a one-to-one function. Alright guys, so the way we can tell if something is a one-to-one function is the horizontal line test. So first it has to be a function, so it means it passed that vertical line test. To be one-to-one though, it has to pass the horizontal line test. So for this left one, it does not pass the horizontal line test, so it is not a one-to-one function. Now the one on the right passes the horizontal line test. It only crosses it at one point, so it is a one-to-one function. Now both of these are functions, but the one on the right is the one that is a one-to-one function. Another thing that we can do with inverse functions is we can verify if two functions are inverses of each other. The way we do that is we do composition. So if f of g of x equals x, then also g of f of x equals x, then we know that those two functions are inverses of each other. Make sure that you check both compositions to make sure that it is an inverse of each other. So for example, it might give us something like this and says, are these functions inverses of each other? So I have f of x equals 2x cubed plus 1, and then g of x equals cube root of x minus 1 over 2. So the first thing I do is I do f of g of x. Okay, remember that tells me that we're going to plug g into f. So I'm going to go ahead and take my g function and plug it into the x of my f function. So I put my g function in blue and I subbed it into the f function. So now I'm just going to go ahead and work this out. So I'm going to go ahead and cube my cube root. So I'm left with 2 times x minus 1 over 2 plus 1. And then I notice that my 2's can simplify. So then I'm just left with x minus 1 plus 1. And then I can combine my like terms. So it equaled x. So I zoom out a little bit. So I know that f of g of x equaled x. Now I need to do the opposite of that. I'm going to do g of f of x and see if I get x as well. So I'm going to go ahead and plug in f into g. So I put the g as the blue and then that f function is black, so I plugged f into g. Now I'm going to go ahead and work it out. So the first thing that I need to do is work that top of the fraction, so I'm going to end up having the cube root of 2x cubed over 2, because I just did positive 1 minus 1. Then I'm going to go ahead and simplify these 2's, so I have the cube root of x cubed, and then the cube root and x cubed cancel each other out, so I end up with just x. So g of f of x equaled x. So since they both ended up equaling x, that verifies that f of x and g of x are inverses of each other. So just to recap, you have to compose both f of g and g of f, and if they both equal x, they are inverses of each other. Alright, with inverses, sometimes we also have to find the inverse of a function. So they'll give us a function, we have to find the inverse. Here's our steps. So first, sometimes it's easy to replace your f of x with a y. Then we'll switch our x and our y. You'll get y by itself. And then remember, we didn't start with y though, so we have to replace it with f inverse of x. And that's what that little -1 means, is inverse. All right, and some important facts about inverses, or some rules that we know that go with inverses, is if f is 1-to-1, we know it will have an inverse. Okay? The domain of f is equal to the range of the inverse, and the range of the f is equal to the domain of the inverse. So what that means is your domain and your range flip-flop when it's the inverse. So the domain becomes the range of the inverse, and the range becomes the domain of the inverse. Okay, and going with that, if I have a point AB on a graph of the function, then I'm going to have the point BA on the inverse of that function. So these are some rules, and the big thing there is that the domain and the range, or your x and your y values, flip-flop. So this is where this comes into play. So it gives us the domain and range of the function and wants us to know the domain and the range of the inverse. And we just talked about it, it's just going to be flipped. So my new domain for the inverse of f would be my range, which was 2, infinity. And over here, my range is going to be what my domain was, which was negative infinity, 4. Okay. Now, for number 2, same thing. Our domain is going to be our original function's range. So my new domain is going to be 4 to infinity. And my range is going to be the domain, which was negative 1, infinity. So I'm going to go over here, parenthesis, negative 1 to positive infinity. So just the big thing is, remember, when we have an inverse, the domain and the range flip. Okay, guys, it wants us to find the inverse. And then once we find the inverse, it wants us to find the domain of the original and its inverse. So remember, the steps of finding the inverse of a function is a few slides back, but our first step was to change f of x into y, just because it's kind of a fancy y. So I'm going to go ahead and write that as y equals 2x minus 3. Now I'm going to go ahead and flip my x and my y. So that's what we're going to go ahead and do. And so I'm going to have x equals 2y minus 3. Okay. Now we're going to solve for y. So I'm going to add 3 to both sides. So we're going to have x plus 3 equals 2y. Now I'm going to divide both sides by 2. So I have x plus 3 over 2 equals y. But remember, we didn't start with a y. We started with f of x. So I need to rewrite this as f plus 3 over 2 equals the f inverse of x. And that was the very last step, is to sub back in that f inverse sign for y. All right. Now, for our f function, our domain, if we think about this, our domain, well, this is just a line. This 2x minus 3 is just a line. So it's going to be from negative infinity to positive infinity, because there's no x values that I cannot put in there. There's no restrictions. For my range, same thing. If it's a line, we know it's just going to go on forever to the going down and up. So it's going to be negative infinity to positive infinity. And sometimes what's kind of helpful is if you think about what this graph would look like. It's down 3, and it goes up 2 over 1, so it's going to look something like this. Sometimes graphing it kind of helps us out, and you can always graph it on the graphing calculator as well. Hey, so now let's go ahead and do the inverse, though. So my domain is going to be my range that I just had, so my domain is still negative infinity to positive infinity. And then my range was my domain from the function, so it's going to be negative infinity to positive infinity. So it really doesn't change for this one. Okay? All right, let's go ahead and look at this next function. So I'm going to go ahead and remember that that's a y, and I'm going to go ahead and switch them right away. So I have x equals y plus 5 cubed. Okay. Now I'm going to cube root both sides. So I'm going to have the cube root of x equals y plus 5. Okay. Now I'm going to move that 5 over, so I have the cube root of x minus 5. And remember, that cube root just stops right at that x equals y, but we didn't start with y, so I'm going to rewrite this as f inverse of x. Okay. Now we have to do the domain range, so my function's domain, okay. Now, if I plug any x value in there, there's no restrictions, right? We can cube any number, can be negative or positive. So it's going to be negative infinity to positive infinity. Okay. And for our range, if you don't know, you can graph this, but the graph ends up looking something like this, shifted over to the left 5. So it's going to go down forever, so it'd be negative infinity and it's go up forever, so it's going to be a positive infinity. So that means when we do the inverse, those flip, but the domain and range are the same thing, so when they flip, it really doesn't do much for us. It's going to be the same thing. Negative infinity to positive infinity for the domain and for the range. Okay. All right, so we're going to do the same thing, but for these ones, it gives us our domain to start with for our functions. So before I even get into this, I'm just going to kind of sketch what this graph would look like. And you can do it in your graphing calculator, but it's going to be a parabola that's kind of shifted over to the left one, and it's going to look like this. Okay, but it's telling us that it's just from -1 to infinity. So really, we don't need the left side of this graph. Really, we're just focusing on that side right there of the parabola. Okay, that's what it tells me, since it's just saying from -1 to infinity. So just kind of keep that in mind when we start to figure out what our range would be. Our range is going to be 0 to infinity. And we'll come back to that when we do the second part, but let's go ahead and find our inverse. So I'm going to switch my f of x to a y and swap it with the x. So I have x equals y plus 1 squared. So I'm going to square root both sides, so the square root of x equals y plus 1. And I'm going to subtract 1, so I'm going to have the square root of x minus 1 equals y, but we didn't start with y, so we need to switch it back to the inverse. Okay. So now I need to talk about what my f inverses, domain and range are, because I already have my functions right over here, domain and range. So now I need to do the domain, which, remember, it's going to be the function's range, which was 0 to infinity. Okay. Now my new range for the inverse is going to be my domain, which was -1 to positive infinity. Okay. So sometimes graphing it kind of helps us see what our domain and range are going to be. And then remember, for the inverse, we just flip that domain and range. Okay. So let's find the inverse of this one. So once again, I'm going to kind of just sketch the graph. Okay. I'd have a vertical asymptote at 3, so it looks something like this. And then I'd have a horizontal asymptote at y equals 0. So it ended up looking something like this. Okay. So then that kind of shows us why our domain is -infinity to 3, and then from 3 to positive infinity. So our range is going to be -infinity to 0, because it goes all the way up to that horizontal asymptote. And then it's going to start back up at 0 and go to positive infinity. Okay. Now before I do the domain range of the inverse, I'm going to go ahead and figure out what the inverse is. So remember, this is y. We're going to swap them. So we're going to have x equals 1 over y minus 3. Now I have to solve for y. Now this one's a little tricky. So what I like to do is I kind of like to cross multiply. So I'm going to have x times y minus 3 equals 1. Now I want to get that y by itself, so I'm going to divide both sides by x. So essentially what happens is that we kind of switch the place of the x in the y minus 3. So I have y minus 3 equals 1 over x. Now I can add 3 to both sides. So my function, its inverse, would be f inverse of x equals 1 over x plus 3. Okay. And my f of inverses domain, remember, it's just the range of the function. So the range of the function was -infinity to 0. And then it was 0 to infinity. Okay. And my range was the domain, which was -infinity to 3. And then 3 to infinity. Right, so a couple things when we get these answers. We get our actual inverse, and then sometimes it'll also ask for the inverse's domain and range. Okay, so really the big thing is when we graph the original, finding the domain and range, and then we just flip it to find the inverse's domain and range. All right, here's your homework assignment. Go ahead and get started.